Hello everyone, and welcome to my YouTube channel. Today, we're going to be delving into the fascinating topic of the multiverse theory. Have you ever wondered if our universe is the only one out there? Well, the multiverse theory proposes that there are multiple universes, each with their own unique properties and physical laws. It's a mind-bending concept that has captured the imagination of scientists and science fiction writers alike. One of the biggest questions surrounding the multiverse theory is how many universes there actually are. In this video, we're going to explore the different types of multiverses proposed by various theories and examine the evidence for and against each one. So sit back, relax, and let's dive into the exciting world of the multiverse theory. Now that we have a basic understanding of the multiverse theory, let's explore the different types of multiverses proposed by various theories. The first type of multiverse is known as bubble universes. This theory suggests that our universe is just one of many bubbles that were created during a process called cosmic inflation. In this scenario, each bubble universe has its own unique physical properties and laws. The number of bubble universes is believed to be infinite, and each one could potentially contain its own galaxies, stars, and planets. The second type of multiverse is known as membrane universes, also called brane worlds. This theory suggests that our universe is just one of many membranes or branes that exist in a higher dimensional space. These branes could potentially interact with each other, causing collisions or even merging to form larger universes. There are different types of brane worlds proposed by various theories, each with its own unique properties. The third type of multiverse is known as the many worlds interpretation. This theory suggests that every decision or event creates a new universe, branching off from the original universe. For example, every time you make a decision, there is a universe where you chose option A and another universe where you chose option B. The number of universes in this scenario is believed to be infinite, with new universes being created every second. The fourth and final type of multiverse is known as mathematical universes. This theory suggests that the laws of physics are based on mathematical principles, and that there are an infinite number of mathematical structures that exist outside of our universe. Each of these structures could potentially represent its own universe, each with its own unique properties and physical laws. So those are the four most common types of multiverses proposed by various theories. While it's impossible to say for sure which one is correct, exploring the possibilities can help us better understand our own universe and the nature of reality. Let's dive a bit deeper into the first type of multiverse, bubble universes. As we mentioned earlier, this theory suggests that our universe is just one of many bubbles that were created during a process called cosmic inflation. So what is cosmic inflation? In the early moments after the Big Bang, the universe underwent a rapid expansion, growing exponentially in size. This expansion is thought to have been caused by a mysterious energy field known as the inflaton field. As the inflaton field decayed, it released energy that was converted into matter and radiation, forming the building blocks of our universe. But here's where things get interesting. During this period of cosmic inflation, quantum fluctuations in the inflaton field could have caused regions of space to expand at different rates. Some regions would have expanded more quickly, while others would have expanded more slowly. These differences in expansion rates could have created bubbles of space-time that are separate from our own universe. The number of bubble universes created in this way is believed to be infinite, and each one could potentially have its own unique physical laws and properties. But how do we know that these bubble universes exist? One piece of evidence comes from observations of the cosmic microwave background radiation, which is the leftover glow from the Big Bang. These observations have revealed tiny temperature fluctuations in the radiation, which could be the result of collisions between our universe and other bubble universes. If these collisions did occur, they would have left a signature in the cosmic microwave background radiation that we can detect. Another piece of evidence comes from the study of dark energy, which is the mysterious force that is causing the expansion of our universe to accelerate. Some theories suggest that the presence of other bubble universes could be causing this acceleration by exerting a gravitational pull on our universe. While we may never be able to directly observe these bubble universes, the idea of an infinite multiverse filled with countless unique universes is both mind-bending and awe-inspiring. Moving on to the second type of multiverse, membrane universes, also known as brane worlds. This theory suggests that our universe is just one of many membranes or branes that exist in a higher dimensional space. So what exactly is a brane? A brane is a hypothetical object that can exist in dimensions beyond our own familiar four dimensions of space and time. It is essentially a sub-universe, a kind of sheet-like structure with its own distinct physical properties. There are several different types of brane worlds proposed by various theories, but they all share the common characteristic of existing in a higher dimensional space. For example, in the Randall-Sundrum model, our universe is a three-dimensional brane that is embedded in a five-dimensional space. Other theories propose branes with different numbers of dimensions. One of the interesting aspects of brane worlds is that they could potentially interact with each other. If two branes were to collide, it could cause a tremendous release of energy, potentially creating a new universe. Some theories even suggest that the collision of two branes could have been responsible for the Big Bang that created our own universe. Another possibility is that branes could merge together, forming a larger universe with different physical laws and properties than either of the individual branes. This merging process could potentially continue indefinitely, leading to the creation of an infinite multiverse of merged brane worlds. While the idea of brane worlds may seem far-fetched, it is based on rigorous mathematical and scientific models. And who knows, perhaps in the future we will find concrete evidence of these higher dimensional structures, expanding our understanding of the nature of reality. Let's now discuss the third type of multiverse, the many worlds interpretation. This theory proposes that every time a decision is made or an event occurs, a new universe is created to accommodate every possible outcome. To illustrate this concept, imagine you are standing at a fork in the road. In our universe, you might choose to turn left and explore one path. But in another universe, you might choose to turn right and explore a completely different path. According to the many worlds interpretation, both of these universes exist simultaneously, with their own distinct realities. This theory was first proposed by physicist Hugh Everett in the 1950s, and it has been a subject of intense debate and discussion ever since. One of the interesting aspects of this theory is that it suggests that there could be an infinite number of universes, each one representing a different possible outcome of every decision and event that has ever occurred. But what evidence do we have for this theory? Unfortunately, it is difficult to test the many worlds interpretation directly. However, some proponents of the theory point to phenomena such as quantum entanglement as evidence that there are multiple universes. In quantum entanglement, two particles can become linked in such a way that their states are always correlated, regardless of the distance between them. Some scientists argue that this can only be explained by the existence of multiple universes. However, the many worlds interpretation has also received a fair share of criticism. Some critics argue that it is an unnecessary and overly complex explanation for phenomena that can be explained by simpler theories. Others point out that the existence of an infinite number of universes creates philosophical problems, such as the question of whether all possibilities must exist somewhere, including horrific events or impossible scenarios. Overall, the many worlds interpretation remains a fascinating and controversial theory in the field of physics, and its implications for our understanding of reality are still being explored. Finally, let's discuss the fourth type of multiverse, the mathematical universe. This theory proposes that the laws of physics are based on mathematical principles, and that everything in the universe can ultimately be described by mathematical equations. The idea that the universe is fundamentally mathematical is not a new one, and has been a subject of philosophical and scientific inquiry for centuries. However, the mathematical universe hypothesis takes this idea one step further, suggesting that mathematics is not just a tool for understanding the universe, but is actually the underlying structure of reality itself. One of the pieces of evidence supporting this theory is the remarkable success of mathematical models in describing and predicting physical phenomena. From the laws of gravity to the behavior of subatomic particles, the universe seems to obey mathematical laws with astonishing precision. Some scientists argue that this suggests that the universe is inherently mathematical in nature. Another piece of evidence comes from the fact that certain mathematical structures and patterns appear repeatedly in the natural world, from the spiral patterns of seashells to the branching patterns of trees. Some scientists argue that this is evidence that the universe is essentially a giant mathematical object. But how does the idea of a mathematical universe relate to the other types of multiverses we've discussed? One possibility is that each mathematical structure or equation represents a different universe, and that the laws of physics in each universe are based on different mathematical principles. Another possibility is that the mathematical universe is a kind of overarching structure that contains all of the other multiverses. In this view, the laws of physics in each universe are simply different expressions of the same underlying mathematical structure. Overall, the idea of a mathematical universe raises intriguing questions about the nature of reality and the relationship between mathematics and physics. While the theory remains speculative, it is an exciting area of research that may hold the key to unlocking some of the deepest mysteries of the universe. In conclusion, we've explored the fascinating concept of multiverses and the different types of universes that are proposed by various scientific theories. From bubble universes to mathematical universes, each type of multiverse raises intriguing questions about the nature of reality and the universe we live in. While we may never know for sure how many universes there are, the exploration of these possibilities can help us better understand our own universe and the fundamental laws that govern it. By considering the evidence for each type of multiverse, we can gain new insights into the mysteries of the cosmos and the nature of existence itself. Thank you for watching, and I hope this video has been an informative introduction to the fascinating topic of multiverses.